Welcome to this explainer. Looking back through human history, it's absolutely full of these incredible stories that just completely defy our basic understanding of what the human body can actually handle. When we hear these wild tales of impossible survival, why is it that our brains immediately jump to the supernatural? We call them magic, we call them miracles. And honestly, it's a lot easier to believe in magic than it is to do the math, right? But today, we're taking a completely different approach. We're going to demystify miraculous human survival and prove that living through deadly conditions, it's entirely about math and physics. We're going to break down the actual science, look at the energy limits, and examine the strict physical parameters that dictate who lives and who dies in literally the worst situations imaginable. Let's get into it.
Moving on to Section 1, the myth of miracles. For centuries, surviving a cataclysmic event basically meant you were either incredibly lucky or favored by some higher power. But as we'll see, science gives us a totally different, incredibly precise lens to view these events through.
So, when we hear stories of humans beating absolutely impossible odds, we really have to stop and ask ourselves, what actually separates a miracle from mechanics? Like, how much of it is just dumb luck versus a strict physical equation? Is it divine intervention, or is it just the right human body being in the exact right physical environment to completely bypass lethal thresholds?
Because people have actually survived these exact extremes without dying. And let's think about why this completely breaks our brains for a second. 160 degrees Fahrenheit, that is hot enough to cause severe third-degree burns and total cellular destruction in just seconds. Or what about surviving the kinetic trauma of being hanged by the wrists? That means placing the entire weight of a human body onto just a few fragile ligaments, which theoretically should just tear and structurally fail under that kind of extreme kinetic load. And atomic blasts? I mean, come on, that is the sudden release of catastrophic thermal and kinetic energy that literally vaporizes steel. Yet, people have walked away from all of these. How did their biology not completely shut down? Well, the answer lies in the math.
Which brings us to Section 2, surviving 2 atomic bombs. To really ground this theory in a specific historical event, we have the absolutely staggering story of Tsutomu Yamaguchi. So, picture this. In August 1945, he was in Hiroshima on a business trip and survived the first atomic bombing. Then, incredibly, and you really can't make this up, he traveled back to his hometown of Nagasaki and survived the second atomic bomb just 3 days later. Surviving a single nuclear detonation is already a statistical anomaly that completely defies belief, but 2? No way. It is so easy to label Yamaguchi as a walking miracle. But his survival wasn't magic. It was heavily dictated by his physical geometry relative to the blasts. And that geometry comes down to exactly 1.9 miles. That was his precise distance from ground zero in both blasts, and it is the exact mathematical difference between life and death. Look, at ground zero of a nuclear detonation, temperatures reach millions of degrees, and the shock wave exerts thousands of pounds of pressure per square inch. Human tissue simply vaporizes. But physics dictates that energy dissipates over distance, following what's called the inverse square law. By the time that catastrophic wave reached exactly 1.9 miles out, the thermal radiation had cooled just enough to cause severe burns rather than instant incineration. The overpressure blast wave dropped to a PSI level that was, deeply traumatizing but wouldn't instantly rupture his internal organs. He wasn't saved by a miracle, he was saved by the math of thermal dissipation positioned just at the absolute outer edge of the lethal boundary. Let's look at how this applies elsewhere in Section 3, heat and suspension extremes.
Because whether you're facing extreme 160-degree heat on one hand or the kinetic trauma of being suspended by your wrists on the other, survival requires finding a very exact mechanical window of viability. Think about it. Your body is a brilliant piece of biological engineering. When faced with 160-degree water, your skin and sweat glands aggressively push back against the thermal energy, creating this micro-layer of evaporative cooling just long enough to delay total cellular breakdown. And your wrist ligaments, they actually have a specific tensile strength. They'll stretch and strain, holding the kinetic load of your body weight right up to their physical breaking point. It's not about somehow becoming invincible. It's about the energy applied not quite crossing that final threshold of structural failure.
And that leads perfectly into Section 4, defining the survival zone. Let's replace that emotional word miracle with the clinical science that explains all of these events. What kept Yamaguchi alive at that 1.9-mile mark is what we call the survival zone. Think of it exactly like the structural load limit on a suspension bridge. Engineers know precisely how many tons of traffic a bridge can hold before the steel cables just snap. Well, the human body works the exact same way. The survival zone is a specific window of pressure, temperature, and radiation resistance. If the environment stays within this strict mathematical window, your biological infrastructure, we're talking your bones, tissues, and internal organs, can technically hold the load and withstand the extremes.
But here's the catch. The margins of survival are razor thin. On the inside of this mathematical window, your tissues hold up. You're protected by your body's natural resistance limits. But take one single step outside the zone, and you face complete vulnerability to lethal extremes. The bridge snaps. Survival isn't some vague floating concept. It's a hard geographic and physical boundary. You are either inside the margins or you are not. It really makes you appreciate how fragile yet incredibly mathematically resilient human life actually is.
Now, shifting gears to Section 5, Engineering Against Armageddon. If we know exactly how the human body survives extreme energy, what happens if we scale that math up?
Well, we can actually take the exact same physics of human survival and engineer buildings to replicate it. A perfect example is the legendary Cheyenne Mountain Complex. Now, this isn't just an office building. It's a massive military bunker carved 2,000 feet deep into the solid granite of a mountain in Colorado. Humans essentially realized that if survival is just a matter of establishing a physical survival zone against lethal energy, hey, we could just manufacture one out of steel and rock to protect against the unthinkable.
And to pull this off, the massive infrastructure inside this complex sits on exactly 1,000 steel springs. And we are not talking about small coils here. Each of these springs is roughly the size of a car, weighing around 1,000 pounds apiece, and together they support independent buildings weighing thousands of tons. So why go to all this trouble? Because to survive a nuclear blast, you have to manage a monumental transfer of kinetic energy.
By specifically designing these giant springs to compress and absorb the violent kinetic shockwave of a direct nuclear strike, we are literally building an artificial survival zone to defy Armageddon. When a blast hits the mountain, the granite shakes, but the springs compress, safely dissipating the deadly kinetic energy before it can tear the structural steel of the buildings apart. Guys, it's the exact same scientific principle as Yamaguchi's 1.9-mile buffer, but instead of using geographic distance to let the blast dissipate, we're using mechanical engineering to forcefully absorb the shock. We literally took the biology of human survival and turned it into world-class architecture. How cool is that? So as we wrap up this explainer, I really want to leave you challenging your perception of the impossible. If survival is just a matter of calculating kinetic energy and following the strict laws of physics, are there truly any miracles left? Whether it's living through a 160-degree shower or engineering a mountain on giant springs to catch a nuclear strike, it all comes down to the math. But honestly, maybe that shouldn't take away our sense of wonder. Because once you truly understand the equations, the real miracle is just the flawless, beautiful execution of physics. Keep questioning the impossible, stay curious, and I'll catch you in the next explainer.